Good morning, everybody. First of all, I'd like to introduce myself. I'm now a postdoc researcher in Yale University. I'm now working with the directions from Professor Grandford and Professor Feng Shao. Today I will present our work, CertiKOS, the certified operating system kernel for cloud computing. Currently, we have a large group of people working on related parts of the project, and each person works on different parts of the project. So, if you are specifically interested in the research area for different members in our team, you are welcome to check our website. And if you have any comments and suggestions for our work, and also we would like to hear from you. And okay, let's begin. First of all, I will introduce the project background and followed by the CertiKOS design implementation as well as its certification. Software is becoming more important in different areas, especially the failures, threats, and vulnerability in software cause users much loss and even disasters, especially for these mission-critical applications. So it is important for users to confirm or evaluate the trustworthiness of this software. And we noticed the recent advancements in the certified software. So we proposed to employ these formal methods to prove the properties of this software. And so we are now currently carrying on our project, advanced development of certified OS kernel. And the research topics of our project include as follows. First, we are trying to introduce new operating system kernels, which can be cache-proof the entire system and the software and these application softwares. And we're also trying to introduce new programming language for certified kernel, like INS. And third, we are trying to introduce new formal methods to prove this, to introduce this automatic proofing for specifically the operating system kernel. And our project is supported by DARPA, and it is divided into 4 stages. And the content I will present here today is basically about 1.5 year progress of our project. So I hope we can get some feedback and comments from all of you. Okay, let's see the problem in cloud computing. In cloud computing, these end users can place their plans on the platforms provided by these cloud providers. And the cloud provider usually employs these infrastructures tools like hypervisor, virtual machine monitor to support the execution of these plans. And these services are usually provided in the open environment. So if the end user wants to use this service, it has to assume that for these components under the red line, they should be trusted. That's the situation for most of these characteristic solutions for cloud computing products. And for this case, they have to face threats as follows. First, these components themselves can be compromised. And second, as the provider, they have full control over these infrastructures. So they can access the space of these plants at will. So the information, privacy, and the execution of these plants cannot be protected, especially for this case when the provider itself is compromised or even malicious. So we think we need some new solution for this problem. Especially we proposed our solution, the CertiKOS certified kernel for computing. And the basic idea is to push down the red line. In our CertiKOS, the resource management facilities will be separated from the old TCP. It will be placed in the user domain, and the CertiKOS will treat the management facilities as well as these clients. They are both treated as untrusted applications. So even when the provider tries to examine some resources, the CertiKOS will also enforce or evaluate these requests. And second, we will try to use the recent advancements in certification research to certify CertiKOS. And third, at the runtime, it is possible to employ this standard hardware-based root of trust to, like TPM, to attest the correct deployment of the CertiKOS. For the trust model of our project, we assume that the hardware is trusted and it is well protected. This is a standard assumption for this modern data center security. And for the trust established on the CertiKOS, we can have two mechanisms to build this trust chain. First, the end user can verify the formal proofs of CertiKOS to confirm the implementation correctness of the kernel. And in the second step, it can employ this hardware-based root of trust, the TPM, to attest the correct deployment of the kernel. For our kernel CertiKOS, this basically handles the resource delegation and isolation. And for the cloud computing environment, basically three types of resources are required for computation, storage, networking, which are corresponding to this CertiKOS RAM as well disk and networking networks. This networks part. And this is a typical resource usage control or isolation process for our CertiKOS. Before runtime, as step one, the client and the management facility will have a negotiation for the client to get its required resources. And the management domain will notify the kernel to record this ownership on behalf of the client. At the runtime, when the client sends the request to the kernel will evaluate the request, and according to the report, it will decide to authorize or deny the request. And even when the management facility tries to access some resources, the request will also be evaluated accordingly. We have several design decisions for how to push the design down. As I have just introduced today, first of all, we try to separate the resource management facility into the user domain, the untrusted application layer. So it will not be placed in the CertiKOS, and the kernel will be kept small. Second, for the resource abstraction, we only abstract the necessary resources for the computing environment. And one special point is that we do not provide file system. We leave it to the application layer. And for the third and important consideration is about the resource scheduling. There is a trade-off between dynamic resource scheduling and the static resource scheduling. We can see the advantages for these solutions for dynamic resource scheduling. It has high efficiency, but from the perspective of certification, it will be more complex and maybe difficult to certify. So actually, we employ the static resource scheduling in our scheme. We are trying to keep the kernel small and make it more easier for certification. And from the second attack side, as we use this static scheduling, it's basically about the spatial partitioning-based resource scheduling. So it can have the potential to resist to these side channel attacks. And Of course, the disadvantage is about the low efficiency. So for current procedure, currently we have the assumption that there are enough computation resources for cloud computing. And one important part is about the resource relocating. And it's possible for the provider to use resource relocating to expose or to interfere with the execution of this client. So, for example, here, if the dynamic